Now there are some special angles for which we can easily find what sine and cosine are, and those special angles are 0, an angle of 0, pi over 6 radians, which is 30 degrees, pi over 4 radians, which is 45 degrees, pi over 3, which is 60 degrees, and pi over 2, which is 90 degrees. So 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Okay. So maybe let's start with theta equals 0. Okay. This is going to be very, very quick. So if the angle is 0, okay, it's okay. There's no angle in some way. Okay, it's an angle of 0. If I look at the coordinates of this point here, which are 1, 0, then those are going to be the sine and cosine. So cosine is 1, sine. So I should write cosine of 0. Cosine of 0 is 1, and sine of 0 is 0. Okay, that's pretty easy. After that, there's the other simple angle is pi over 2. So pi over 2 is when the angle is 90 degrees. Okay. So like this. Okay. In this case, the angle, so theta, is this. Okay. And I'm looking at this line here, okay, which intersects the circle at the point 0, 1. That's going to be cosine and sine. So cosine of pi over 2 is 0, and because the x-coordinate is 0 at that point, and sine of pi over 2 is 1. Okay, so similarly, cosine of 90 degrees is 0, and sine of 90 degrees is 1. Okay, so that's pretty easy. Let's look at pi over 6 now. Well, actually, let's start with something a little slightly easier. Pi over 4, which is 45 degrees. So to get the values of sine and cosine, we first work on a triangle, and then we're going to add those values to so on a right triangle with a 45 degree angle, 45 means that you've got an isosceles triangle. Okay, because if these two angles are identical, because they're both 45 or pi over, I should actually write pi over 4. Let's draw a bigger triangle actually. This is the right angle. This is pi over 4. This one's also going to be pi over 4, right? 45, 45, because they need to add up to 90. So we've got an isosceles triangle. So those two sides are identical. So let's call them A and A. If this hypotenuse is 1, which is actually what would happen if that triangle would get inscribed in the unit circle. So the hypotenuse is 1. Right, so we're actually I can add the unit circle so that you can see better where it is. It's like that, right? Like this. So this is its center. Okay, and right now we're looking at this angle of theta, which is pi over 4. So the coordinates here will be the cos of pi over 4, and this will be the sine of pi over 4. Okay, and those will actually be the values of A and A. Okay, so how do I find A? I'm just going to use the Pythagorean identity. So the hypotenuse squared is the sum of the squares of the two, the lengths of the two legs of the triangle squared. So this is 1 plus 2a squared. So 1/2 is a squared, and that makes a equal to 1 over the square root of 1/2, which is the same thing as square root of 1 over square root of 2. But square root of 1 is simply 1. So it's 1 over root 2, and as I told you before, often we rationalize the denominator. So if we multiply and divide by root 2, we get root 2 over 2. So those are the coordinates. Root 2 over 2, root 2 over 2, so we can add this. So the cos of pi over 4 or 45 degrees is root 2 over 2, and same thing for the sine. It makes sense that they're equal, by the way, because at a 45-degree angle, you've got the line here, y equals x. So on this line, the x and the y coordinates are equal. So of course, the x and y coordinates are equal when that line intersects the circle. Next angle, pi over 6 or 30 degrees. Okay, so once again, we can work within our unit circle, and these are the main axes. And we've got an angle of 30 degrees. 30 degrees basically splits 90 degrees into 3 parts, so it would be somehow like that. So this is pi over 3. Okay, theta is pi over 3. Again, this point here will be cos of pi over 3, sine of pi over 3, and those will correspond to the lengths of the legs of that right angled triangle. So this side is 1 since it's the hypotenuse, and we're kind of missing the adjacent side and the opposite side. We're missing everything here. Well, the two sides. So here's what I'm going to do. I'm going to redraw that triangle. Okay, this is theta here, which is pi over 3. Actually, let's write pi over 3 instead of theta. Pi over 6. I wrote pi over 3. Sorry, this is pi over 6. This is 90 degrees. If this is pi over 6, the complementary angle is, what is it? Well, it's pi over 2 minus pi over 6. So that's 3 pi over 6 minus pi over 6. That's 2 pi over 6, or if you prefer, pi over 3. So this complementary angle here is pi over 3. You know what? Let's make this slightly bigger. So we said pi over 6, pi over 3, 90 degrees. And here's what I'm going to do. I'm going to add an identical triangle here. Okay, so this is 90 degrees. This is also going to be pi over 6, and this is also going to be pi over 3. Like what kind of, like the large triangle that I now have, what kind of triangle is that? It's a special kind of triangle. It's a triangle where all the angles, the inner angles, are the same. They're all equal to pi over 3, because notice that this bigger angle here, that's pi over 6 plus pi over 6, that's also pi over 3. So all these sides, okay, must be identical because it's an equilateral triangle. Equilateral triangle. So all sides are equal. So in particular, that side was 1, remember? So this side is 1. So this side here must also be 1, which means that this side here must be half of it. So here we go. We've got a first value on our triangle. The opposite side turns out to be 1/2. So this is actually the sine of pi over 3. And to get a, that's easy. I can use the Pythagorean identity. So 1 squared is going to be equal to a squared plus o squared. But now I know that o is 1/2. So this is going to be 1/2 squared. And all I need to do now is solve for a. So a is going to be 1 minus 1/4 or 3/4. So a will be the square root of that. So it's going to be square root of 3 over square root 4, and square root 4 is 2. So I get root 3 over 2. So this is the cosine of pi over 3. So let's write it here. Cosine pi over 3 is root 3 over 2. Sine of pi over 3. Still writing pi over 3, and I shouldn't. It's pi over 6. Sine is 1/2. Okay, so that was harder to get. And I'm going to keep working on that triangle, maybe use a different color just to not get things mixed up. If I look at this point here, that's, okay, remember that pi over 6, it divides 90 degrees into 3 parts. So if this is another pi over 6 here, overall this is 2 pi over 6 or pi over 3. Okay, now this point here, these 2 points, if you look at them, this one and this one, okay, they're actually obtained by, or what they have in common is that if you take, if you draw a line, the line y equals x here, okay, this, if you reflect this point across the line, you're going to get the other point, okay. So if I reflect this, I'm going to get the other point. Now this other point, its coordinates are cos of pi over 3 and sine of pi over 3. But you'll recall that if you reflect a point across the line y equals x, it changes the coordinates of x and y. Right? This is something we do, for example, when we have a function and we graph its inverse, we interchange the coordinates of x and y. So same thing here, same kind of a geometrical property. So the cosine of pi over 3 is actually the sine of, oh, and I just noticed I made a mistake here too. So let me correct this. This is not pi over 3, this is pi over 6. So the cosine of pi over 6 is actually the same thing as the sine of pi over, cosine of pi over 3 is the same as the sine of pi over 6. Sine of pi over, or pi over 3 is the same as the cosine of pi over 6. And those are, so basically if I take the coordinates here and you switch them around, you're going to get the coordinates of the point when the angle is pi over 3. So you just flip those around. So finally, let's maybe summarize everything, okay? We've got our unit circle, and we've got some pretty important angles. The angle 0, pi over 2, pi over 4, which is right in the middle, and then a third of the way, that's pi over 6. So let's add it here. This is 0, pi over, or maybe I should, you know what, I'm going to put them inside the circle, because outside I want to put the coordinates. So this is 0, pi over 6, pi over 4, this is pi over 3 over there. It's not in the middle, by the way. It looks like in the middle of my picture. Maybe I'll correct this. Like that. I'll add my circle again. So remember that the pi over 6 and pi over 3, they sort of cut the arc length in the first quadrant. By the way, I don't know if I mentioned this. This is quadrant number 1. This is quadrant number 2. This is quadrant number 3, and this is quadrant number 4. So in the first quadrant, it splits the arc corresponding to an angle of 90 degrees, or pi over 2, into 3 equal parts. So this is pi over 3 here. And what we found is that the coordinates, so those are the values of sine and cosine, right? So the coordinates here are, this is of course 1, 0. So cosine is 1, sine is 0. This we found as being root 3 over 2 and 1/2. So those are values we're going to have to remember by heart. Root 3 over 2, 1/2. If you don't know which one goes first, look at this triangle here, okay, this one here. Obviously this side here is larger than the height, okay, the base is larger than the height. So for the base, for the x coordinate, you want to choose the largest of those two numbers. So this is how I used to remember it in high school. So the largest of the two is the one that has the largest the numerator, so root 3 over 2. So root 3 over 2 goes first. For this one, you just flip them around. So 1/2 root 3 over 2. And same concept applies here. If you look at this triangle, its base is definitely smaller than the height. So for the height, for the y, you want the largest of the two numbers. And for this, for pi over 4, we get identical values. Okay, so really the thing you have, the quantities you have to remember are these three: root 3 over 2, 1/2, and root 2 over 2. And for this one, it's 0, 1. So those are the sine and cosine and sine for an angle of pi over 2. And those are the only points we'll actually need to remember. There are going to be more. Actually, we're going to add more points here, but we'll see that they all relate to the points we have in the first quadrant. And maybe I'll show you another way to remember sine and cosine for different angles. This is something I was shown by a teacher here at the college. It's kind of cute. So for the angles, you put the special angles we have here: 0, pi over 6, pi over 4, pi over 3, and pi over 2. Notice that they're in increasing values of angles because the denominators just gets smaller each time. So 6, 4, 3, 2. So the angles are getting larger and larger. So this is 0 degrees. This is 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So for the sine, you would look at the y coordinates, 0, 1/2. So those are the ones. But I'll show you a way of, instead of looking at your trig circle, how to remember it. So sine, you have to know you start at 0 because you start here at this point and the y value is 0. So this is going to be 0. I'm going to write 0 in a funny way. We're going to write it as 0 over root 2. But realize that this is the same as 0. If you divide 0 by root 2 or by whatever positive or non-zero number, you're going to get 0 no matter what. Pi over 6, it's going to be, let's look at it's going to be 1/2, but I'm going to write it as something that's also kind of funny. Root 1 over, root 1 over, root 1 over 2. Actually here, I'm going to just change it. It's not root 2 I want it here. It's a 2, just 2. What I wanted to write is root of 0. Okay, so let's backtrack. I'm going to write my 0 as root of 0 over 2. Root of 0 is 0, so 0 over 2 turned out to be 0. 1/2, I'm going to write it as root of 1 over 2, which is the same thing, obviously, as 1/2. Root 4, pi over 4, look at the y value. It's root 2 over 2. Okay, so I'm going to keep it like that. Pi over 3, the value is root 3 over 2. I'm going to keep it like that. And at pi over 2, the y value is 1. But 1, I'm going to write it as root 4 over 2. And notice that this is 1 because root 4 is actually equal to 2. So 2 over 2 is 1. And look how cute that is. So basically, to remember the values of sine, you put 2 in the denominator all the time, and then you just write root 0, root 1, root 2, root 3, root 4, and it gives you all the values of sine from 0 to pi over 2. For cosine, it's kind of backwards. You start with 0 here, and you go the other way around. So you increase the number inside the square root, but going from left to right, right to left this time. Anyway, and then it gives you the values of sine and cosine. So personally, this is not how I was taught how to remember sine and cosine. You could use that trick, or my trick is really just remembering those and knowing how to put those numbers correctly for all the points that are in the first quadrant. Essentially based on what I was telling you before. Like when you draw this triangle, you know that the one's root 3 over 2, the other one's 1/2, and then you just have to understand that the base is larger than the height, and then root 3 over 2 comes first. So this is my way, but if you prefer, you could also use something like that here. But of course, never write as the final answer like the sine is root 0 over 2. Simplify it to 0, of course. So this is just for remembering the values. And again here, this one, you would never write root forward 2. You would write 1 as your final answer.